Welcome to an example on how to solve an application problem using a system of linear equations. In this example, we're given that movie tickets cost $7 for adults, $5.50 for children. There are 218 seats in the theater. A total of $1,463 was collected in ticket sales for the sold-out Saturday matinee. How many adults and how many children were in the theater? So there are three parts to this question. Part A, write an equation representing the total number of tickets sold. B, write an equation representing the total amount of money collected from the sale of all tickets. And then finally C, we want to solve the system of equations and answer the question. Let's highlight the important information here. Adult tickets cost $7 each. Children's tickets cost $5.50 each. There are 218 seats in the theater. A total of $1,463 was collected, and the theater was sold out on this day. So there are two unknowns here. We don't know how many adult tickets were sold or how many children's tickets were sold. So let's use variables to help us remember what these represent. So let's use A for adults and C for children. So A is equal to the number of adult tickets, and C is equal to the number of children's tickets. To write the equation representing the total number of tickets sold, the important information here is that there are 218 seats in the theater, and it was sold out on this day, and therefore there had to be 218 tickets sold. So for our first equation, we'd have A, the number of adult tickets, plus C, the number of children's tickets, must equal 218. Now for part B, we're asked to write an equation representing the total amount of money collected from the sale of all tickets. Well, the adult tickets cost $7 and the children's tickets cost $5.50. So the total amount of money collected would have to be $7 times the number of adult tickets, which is A, so $7 times A, plus $5.50 times the number of children's tickets, which would be $5.50 times C. This must equal the total amount collected, which we know is $1,463. So for our second equation, we'll simplify and drop the dollars. So we'd have the equation 7a plus 5.5c equals 1,463. So our system of equations consists of this equation and this equation. So for part C, we want to solve this system. Let's go and do this on the next slide, and then we'll come back and answer the question. To solve this system of equations, we can use addition or substitution. Because we can easily solve this first equation for A or C, let's use substitution. So if we solve this first equation for A, notice that A would be equal to 218 minus C when we subtract C on both sides. Now that we have this first equation solved for A, we'll substitute 218 minus C for A in the second equation. So performing that substitution, we'd have 7 times the quantity 218 minus C plus 5.5C equals 1,463. Next, we'd clear the parentheses by distributing here. 7 times 218 is equal to 1,526, and then minus 7C plus 5.5C equals 1,463. Combining the like terms here, negative 7C plus 5.5C is negative 1.5C. So we have 1,526 minus 1.5C equals 1,463. We'd subtract 1,526 on both sides. Simplifying, we have negative 1.5C equals 1,463 minus 1,526 is equal to negative 63, dividing both sides by negative 1.5. Simplifying, we have C equals negative 63 divided by negative 1.5 is equal to 42. So this tells us there were 42 children's tickets sold, and therefore there were 42 children in the theater. And now we'll find A using the equation A equals 218 minus C. So A is going to be equal to 218 minus 42, which equals 176. So we know there were 42 children in the theater and 176 adults. Before we write this as a sentence, though, let's check this solution. To check the solution, we want to make sure it satisfies both of the equations in our system. So for a plus c equals 218, we would have 176 plus 42 equals 218, and this sum here is 218, so this checks. We also have to check the second equation, 7a plus 5.5c equals 1,463. So we'd have 7 times a is 176 plus 5.5 times c, which is 42, equals 1,463. So this product is 1,232, and this product is equal to 231, and this sum here is 1,463, and therefore our solution also satisfies the second equation. So going back to the first slide, let's now put our answer in a sentence. Again, our solution was a equals 176 and c equals 42. So the question was how many adults and how many children were in the theater? We can say that there were 176 adults and 42 children in the theater. I hope you found this helpful.
Okay, welcome back. Today we'll be talking about applications using systems of equations. So let's go ahead and take a look at our first example. Assume all Phoenix College courses are either worth 3 or 4 credits. The cross-country team is taking a total of 40 courses that are worth 144 credits. How many 3-credit courses and how many 4-credit courses are being taken? So the first thing is we need to identify our unknowns. Let's let x equal the number of 3-credit classes and y equal the number of 4-credit classes. The first thing we need to recognize here is that the team is taking a total of 40 courses. Therefore, our first equation would have to be x plus y must equal 40. Now the next equation is going to deal with the total number of credit hours. There's a total of 144 credit hours, but every x is worth 3 credits, so we'd have 3 times the number of 3-credit courses, plus every y is worth 4 credits, so 4 credits times every 4-credit class must equal the total number of credit hours, which is 144. Now remember, we can solve this system using a variety of methods. I'm going to use the elimination method, and I'm going to eliminate the x terms. So since this is 3x, I want this to be a negative 3x, therefore I'll multiply this first equation by negative 3. So the result would be negative 3x minus 3y is equal to negative 120. And we can leave the second equation in its original form. And the reason we did this is now, since the x terms are opposites, these will add to 0. This will add to a y or a 1y. And this will add to 24. So y equals 24, therefore we know the team is taking 24 4-credit courses, but we have to perform substitution into one of these original equations in order to find x. It seems like it'd be pretty easy to use this first equation to solve for x. Since we know y is 24, we can solve this for x equals 16. Therefore, we can conclude the team is taking 16 3-credit courses since x equals 16, and 24 4-credit courses since y is equal to 24. Let's go ahead and take a look at this example. HomeMart charges $3.50 for a CFL light bulb, and Supply Depot charges $2.50 for a CFL light bulb that doesn't last quite as long. If your apartment complex lost the invoice but knew they purchased 300 bulbs and spent $885, how many bulbs were purchased from each store? So again, we'll identify our variables. Let's let x equal the number of bulbs from HomeMart and y equal the number of bulbs from the Supply Depot. Since we know we purchased 300 light bulbs, we should be able to conclude that x plus y must equal 300. Next, we're going to have a cost equation. we know they spent $885, but every X costs $3.50. So 3.5 times X plus every Y costs $2.50. So that'd be $2.50 times the number of bulbs purchased from Supply Depot must equal $885. Now I'm going to use elimination, and I'm going to eliminate the Y terms this time. However, I could also use the method of substitution. So if I want to eliminate the Y terms, I'll multiply this first equation by negative 2.5, since this is a positive 2.5Y. So the result of multiplying everything by negative 2.5 would be negative 2.5x minus 2.5y equals negative 750. We'll leave the second equation in its original form. So when we add these equations together, the y terms are opposites. That will simplify to 0. So we're left with x equal to 135. So we know that there were 135 bulbs purchased from, there were 135 bulbs purchased from the Home Mart store. Since we know the sum of x and y must equal 300, we could replace x with 135, but you can probably see that since the sum equals 300, y must equal 165. As a result, we can conclude 135 bulbs were purchased from Home Mart and 165 bulbs were purchased from Supply Depot. Now let's take a look at a different type of problem. Groundworks charges $8 per pound for premium roast coffee and $4.50 for value roast coffee. How much of each type should be used to make a 10-pound blend that would cost $5.90 per pound? Again, this is important that we identify what our variables represent. X will be the amount of $8 per pound coffee, and Y will equal the amount of $4.50 per pound coffee. Since our blend will weigh 10 pounds, we can conclude that x plus y must equal 10. The next equation will be what I'll call either the cost or value equation. Every pound of x costs $8, so $8 times x plus every pound of y costs $4.50 must equal the value of the blend. Well, the value of the blend is $5.90, but it has to be times the amount, and the amount will be the sum of x and y. So what we have here is $8 times the amount of x plus $4.50 times the amount of y must equal $5.90 times the amount of the mix, which would be the sum of x and y. Now to solve this system, I am going to use the substitution method, and what I'm going to do is solve this equation for x. I'll subtract y on both sides. Now let's rewrite this equation performing substitution. We would have 8 times x, which is 10 minus y, plus 4.5y must equal 5.9 times x plus y. But we can save some time if we recognize that x plus y does equal 10, so we'll replace this with 10. We have one equation with one unknown, so we now just have to solve this equation and we'll have y. So let's go ahead and clear the parentheses and solve. So here I distributed and here I multiplied by 10. Let's combine our like terms. Now we'll subtract 80 on both sides. That would give us a negative 21 on the right side, dividing by negative 3.5. We have y equal to 6, so therefore we have 6 pounds at $4.50. We can do mental substitution here. X is equal to 10 minus y, or 10 minus 6, so we can conclude that x equals 4. So we can conclude the 10-pound blend will consist of 4 pounds at $8 per pound and 6 pounds at $4.50 per pound. Okay, we have time for one more. A train leaves Prescott, Arizona and travels north through the Grand Canyon at a speed of 25 miles per hour. 1.5 hours later, an express train leaves a parallel track and travels north at 60 miles per hour. How far from the starting station will they meet? So this problem involves the formula distance equals rate times time. So let's go ahead and record what we know in a table. So the idea behind this problem is train 1 leaves the station traveling 25 miles per hour, and then 1.5 hours later, train 2 leaves the same station on a parallel track. It's traveling faster, and the question is, how far from the starting point will they actually meet? Somewhere out here, they'll be in the same place at the same time. So let's set this up. In either case, we don't know the distance. So for the slow train, I'll call this distance 1, d sub 1. The rate is 25 miles per hour. We don't know time, so we'll set time equal to t. Now for the faster train, again, we don't know the distance, so we'll call it d2. But we should recognize that when they meet, d1 will equal d2. The rate of the faster train is 60 miles per hour. However, since this train is leaving 1.5 hours later, we must represent the time as t minus 1.5. Since this train has 1.5 hours less time than train 1, we have to represent the time as t minus 1.5. So our first equation is d equals 25t, and our second equation is d equals 60 times t minus 1.5. Since we want to know when they're going to meet, we know that these two d's would be equal to each other. So what we can do here is solve this system using substitution. Wherever we see a d in the second equation, we can replace it with 25t. So performing the substitution, we would have 25t is equal to 60 times t minus 1.5. So we'll distribute here, isolate t on both sides by subtracting 60t on both sides. That would give us negative 35t equal to negative 90. Dividing both sides by negative 35, t is approximately 2.57 hours. Now the question asks how far from the starting station will they meet? So this is not the answer we're looking for. So to find the distance, we have to pick one of these equations and replace t with 2.57. Let's go ahead and use the first equation. Multiplying here, we're going to get approximately 64.25 miles. So after 64.25 miles, these trains will be in the same position at the same time. I hope you found this video helpful.
A chemist needs to make 2 liters of a 15% acid solution from a 10% acid solution and a 35% acid solution. So we're mixing the 10 and 35% solution to create 2 liters of 15% solution. We want to know how many liters of each should she mix to get the desired solution. So we're going to need two variables here as well as two equations. Let's let x equal the number of liters of the 10% solution, and we'll let y equal the number of liters of the 35% solution. Now let's see if we can write our two equations. We know after mixing these two amounts, we'll have exactly 2 liters of the 15% solution. So our quantity equation will be x plus y must equal 2 liters. The second equation is going to deal with the concentrations of each solution. Since x is equal to the number of liters of the 10% solution and y is equal to the number of liters of the 35% solution, 10% times x, or 0.10 times x, plus 35% times y, or 0.35 times y, must equal 15%, or 0.15, times the total amount of the solution, which is 2 liters. So here's our system of equations that we have to solve. The form of the first equation will be good to work with, but let's transform the second equation before we solve the system. Let's start by eliminating the decimals. If we multiply everything by 100, it's the same as moving the decimal point to the right 2 places. So we can write this as 10x plus 35y equals, and this would be 15 times 2, which is equal to 30. So now we'll solve the system of equations using these two equations. So again, we have x plus y equals 2, and then we have 10x plus 35y equals 30. Now we can solve this algebraically using elimination or substitution. If we call this equation 1 and this equation 2, we could very easily solve this first equation for x or y. To solve this for x, we would subtract y on both sides. So using equation 1, we would have x equals 2 minus y. And then we can perform substitution into equation 2. If x is equal to 2 minus y, we can replace x with 2 minus y. Now equation 2 after substitution would be 10 times 2 minus y instead of times x plus 35y equals 30. And now we have one equation with one variable, so now we'll solve for y. We have 20 minus 10y plus 35y equals 30. Well, here we have two y terms, so we can combine these two terms. Negative 10y plus 35y is 25y, so we'll have 20 plus 25y equals 30. Subtract 20 on both sides would give us 25y equals 10. Divide both sides by 25. And we have y equals 10 25ths, which does simplify. There's a common factor of 5 here. So we have y equals 2/5. Remember, y is the number of liters of the 35% solution. So as an ordered pair, we know that y is equal to 2/5. But we still have to go back and determine x. But we do know from before x is equal to 2 minus y. So we'd have 2 minus 2/5, which is 1 3/5. So we have 1 3/5 liters of the 10% solution. We may want to convert these to decimals. 3/5 is the same as 0.6. So the mixture contains 1.6 liters of the 10% solution, and 2/5 as a decimal would be 0.4 liters of the 35% solution. Okay, I hope you found this helpful. The Nut Shack sells hazelnuts for $6.80 per pound and peanuts for $5.30 per pound. How much of each type should be used to make a 37-pound mixture that sells for $5.91? Let's first define the variables to represent the unknowns. Let's let h equal the number of pounds of hazelnuts and p equal the number of pounds of peanuts. Because the mixture will be 37 pounds, we know that h plus p must equal 37. Now I'll write a second equation using the cost. The cost of the hazelnuts times number of pounds of the hazelnuts plus the cost of the peanuts times number of pounds of peanuts must equal the cost of the mixture times the number of pounds of the mixture, which means $6.80 times h, or 6.8h, would give us the cost of the hazelnuts plus $5.30 times p, or 5.3 times p, would give us the cost of the peanuts, and this must equal the total cost of the mixture, which would be $5.91 times 37 pounds, or 5.91 times 37. So now to determine how many pounds of hazelnuts and how many pounds of peanuts the mixture will have, we need to solve this system of equations. 5.91 times 37 is equal to 218.67. So let's write the second equation as 6.8h plus 5.3p equals 218.67. So now we can disregard this equation here. And at this point, we need to decide whether we want to keep decimals in the second equation or multiply through by a value to clear the decimals from the equation. If we do want to clear the decimals, notice how, because the decimal on the right has two decimal places, we would have to multiply both sides of the equation by 100. So let's go ahead and clear the decimals from this equation by multiplying both sides by 100. So we'll multiply the left side by 100 and the right side by 100. By doing this, 100 times 6.8h would be 680h, plus 5.3p times 100 is 530p. On the right, 218.67 times 100 is 21,867. So now we'll go ahead and disregard this equation as well, and we'll solve the system of equations. H plus p equals 37, and 680h plus 530p equals 21,867. Let's go ahead and solve this system of equations on the next slide. We need to decide whether we want to solve this system by using substitution or elimination. Because we can easily solve this first equation for h or p, let's use the method of substitution and solve this first equation for h by subtracting p on both sides of the equation. So if we subtract p on both sides, we have h equals 37 minus p. Now that we have the first equation solved for h, we can perform a substitution for h in the second equation. We can substitute 37 minus p for h, which will give us one equation with one unknown. Performing this substitution, we would have 680 times the quantity 37 minus p plus 530p equals 21,867. Notice now we have an equation with one unknown, which we can now solve for p. To solve for p, for the next step, let's clear the parentheses here. 680 times 37 is equal to 25,160. And we have minus 680p plus 530p equals 21,867. Combining like terms, negative 680p plus 530p is equal to negative 150p. So we have 25,160 minus 150p equals 21,867. Next, we isolate the p term by subtracting 25,160 on both sides. Simplifying, this simplifies to 0, so we have negative 150p equals 21,867 minus 25,160, which is equal to negative 3,293. And our last step to solve for p is to divide both sides by a negative 150. Simplifying on the left, this simplifies to 1p or p. Now we need to find this quotient, but the directions do say to round to the nearest pound, which means we'll round to the ones place value. Negative 3,293 divided by negative 150, rounded to the ones place value, would round to 22. So now we know the mixture will contain 22 pounds of peanuts. We still need to determine the number of pounds of hazelnuts, so we'll substitute 22 for p in this equation here, where we have h equals 37 minus p. So because h equals 37 minus p, and we now know p is approximately 22, we know h is equal to 37 minus 22, which is equal to 15. So now we know the mixture contains approximately 22 pounds of peanuts and 15 pounds of hazelnuts. So going back to the first slide, again we just found h is equal to 15 and p is equal to 22, or at least approximately, and therefore the mixture has 15 pounds of hazelnuts and 22 pounds of peanuts. I hope you found this helpful.